So good evening, everyone. Thanks for joining us. Apologies for actually making it on the Thursday afternoon or Thursday evening before Easter. I completely forgot about it when I sent out the invite a few weeks ago, so I do apologise, and hopefully we'll get through this quickly. So please let me know in the chat if you have any questions, or if you need me to go over something a bit clearer. So I've just put up here on the screen a quick agenda. So it should take us between 15 and 30 minutes, depending on how many questions there are. So we're going to jump ahead from what I usually present, which is a bit more of an overview about Sonar and code quality, and talk a little bit about what we're trying to achieve with the diagramming of execution groups. So within our product, within MB Precise, we have a couple of rules around, I guess we call them preventing snowflake setups. And snowflake setups are essentially installations of software or deployments of software where every one of them is slightly different. So it's usually resulting from some manual step that someone has to do in a development environment, which is slightly different when they deploy to a test environment, which might be slightly different to when they deploy to a production environment. And what ends up happening is one of their steps gets missed or misdocumented, and lo and behold, when something goes into a new environment, it breaks. So thinking about those sort of conditions or those sorts of situations within the plugin, we've developed some rules around this. So one of them is where we look into the deployments descriptor of the XML file for the Ant build to see what's actually been deployed and where. So we're trying to match up what flows have been deployed against what execution groups, and whether or not they're being deployed consistently. That's well and good, but there's a couple of, I guess, extra thoughts around that. One is there's no guarantee that that's how teams are deploying into a particular environment. There probably are quite a few teams out there that actually don't do production deployments through Ant. They might use some other tool. The other thing is there are probably some teams out there that the execution environment or the broker environment may be configured on the fly, and it might change from period to period depending on how things are operating. So what we're trying to look at is fill that gap between what we can do with static analysis of the code and what we can do with runtime analysis of the code. So in the first point, the first step in this process is to actually give our architects and the developers some sort of insight diagrammatically of what is actually happening with the execution groups. So just to go into other diagrams. So this is our Sonar console. So within our console, we've been developing code coverage, and so code coverage comes up in our console. Which I'll just run here. Oops. Which I'll just bring up here. For some reason, so code coverage, I just need to put the configuration back. So code coverage at the moment comes up in two places. One, it comes up in within the tool, within Sonar itself, which we'll just see here. And it comes in via something called the generic code coverage file. So what we do, or what we've done, is we've created additional Ant tools and whatnot to create let me just find it, to create the generic code coverage formatted file, which we've included here. So what we'll do is when we run our test cases, and I won't run them here at the moment just because there's a little bit of an issue with my local broker running, but when we run our test cases, the test cases at the end of them record essentially what's being given back from the execution, say, well, what was tested. And you end up with a little bit of an overview of the SQL. To say what's been tested, and then also what we've done also is we've fed that into our documents or into our diagrams. So what we can see here is we've got a fairly simple set of flows. and these flows. So these flows are what we can see in our code, and we've merged that information with our test information. So what we can say here is we've got some information about what's being tested, which is green, which you can see here, and what hasn't been tested, which is red. So that's merging our source code and our runtime information into that particular diagram. So straight away, from a developer's perspective, we can see what's what as far as testing our flows go. So we can see which ones have been tested, which ones haven't, and so we can sort of hopefully gradually improve the quality of our testing, or our regression testing. Now we've done something similar. We've taken a similar approach with the execution group information. Now, what we've developed is a little execution group, I guess you call it extractor, which takes information from the runtime and generates what we call a runtime XML file. And essentially it's just a list of broker, of execution groups within a broker, a little bit of information about some ports, and the list of the flows that are deployed to each broker. And it gives us this reasonably, interesting but not very pretty XML file. What we do then, we feed that into our Sonar analysis using our Sonar properties file, which we configure through a MB precise specific setting called sonar.mb.runtime file. We import that when we execute, and as part of that, or part of the automatic diagram generation, at the end of it, we end up with a list of execution groups and flows. So where an execution group, when a flow exists in an execution group, it's marked and it's listed here in the execution group list, and where it's not, it's left empty. So we can see here straight away, if we're running against a production, like running this analysis against a production-like environment, we can see that some of our flows are deployed into multiple execution groups. Some of our flows aren't deployed at all into any execution groups. So this gives us a little bit of visual information of see what's deployed and where it's deployed, and from there we've extended that into the diagram above. As I said, it's fairly contrived and simplistic diagram because it's only got 6 flows and they're not really interconnected. But this is just a demonstration to give you an idea of what's capable of doing. So we can see again the execution group, the number of flows, and what we can see diagrammatically is when we click on in the execution group, we can see that this particular, so even though this execution group's got 3 flows, it's highlighted the 2 flows it knows about, and there sounds like there's a third flow which isn't actually in our source code, which has been deployed into that execution group, which may or may not be a warning bell to developers or architects to say, well, how did that flow get there if it's not part of our code? But it could be a part of another source code tree, or it could be some other reason that it gets there. So we can see here a diagrammatic representation of which flows are deployed to which execution groups. So again, this is a contrived example, but if we think about extending this gives us a lot of additional potential information that we can put in front of the user. Particularly also if we can start taking other architectural information and put it inside this this extract file. So at the moment we haven't done that. That's the something coming up for our next release. Where the intention for the next release is that we will, as well as providing a list of execution groups that contain different flows, we'll also start applying configuration rules against known execution groups that people can check in and configure. So what we were looking to apply that with is for one of our customers who was looking to start improving the security of broker. So one of the first ones we'll be looking to doing is flagging execution groups that, for example, write to the file system. So what teams might want to do is, because we know when certain parts of the file system are going to be written to, the execution group that's running that, or the user that the execution group is running for, needs to have the privileges to write to the file system. So that may mean that particular execution group has heightened permissions in the sense that it can actually do things, not just read messages, but can also write files and whatnot. So what we might want to do is look to petition, or make an architectural decision to petition our Our flows, that all the flows that read and write to the file system go into that execution group. So then an extension of that may be that we can write a rule that says, well, if you are deploying, or if you do have flows configured that read to the file system or write to the file system and they're not in that particular execution group, we'll flag that as a warning back to the developer to say, well, we need to look at where this flows actually end up being deploying to, or we can flag with the architect to say, well, where should this flow be deployed to? Because according to the rules that we've set up, this particular execution group should or should not have a particular type of flow, and that particular type of flow has some characteristic like a reading from MQ or writing to MQ or a SOAP node. Another rule we might be looking to enforce, we might decide that only certain execution groups can be, for example, client-facing. So what you might say is that only that certain external URLs or certain URLs can only be in certain execution groups. And that way, again, you can petition your system so that if you want to take down external processing, you only have one execution group you have to suspend, so other parts of the system can still execute. And another rule we might look around is performance, where we might say that certain types of flows, and it may not be initially very granular, but it might be, for example, MQ flows all have to be in at least one execution group to make sure that for load balancing and stability and scalability. So we might have a rule that says all the flows with MQ have to be deployed to at least 2 execution groups and at most 3 execution groups, for example. So as we roll this out, or as we discuss customers about rolling these rules out, we'll get more clarity about what these rules are going to look like. As I said, it is Easter, so I'll try not to take too much of your time up. That's pretty much the end of the agenda, or the end of what I had planned to talk about. If there's no questions, we'll look to finish a few minutes early and let everyone go do other things. Right, so it doesn't sound like there's any questions. So hopefully everyone got something from this presentation, and we'll be following up with some more emails a bit later on when we've got some more clarity around how we're going to be setting up some of these execution group based rules. So we're talking to some customers actually next week about it. So once we get a bit of clarification about what are our first couple of customers that will be using it, how to use it, will have a bit more of a prototype, a bit more of a stereotype that other customers can look to use. So thank you again for joining us. I hope you got something from it, and please enjoy your Easter, and I will chat to you later.